Hey everybody, this is Larry. This is day 23 of the November Leetcode Day. Challenge you to like button and subscribe on Drum and Discord. Let me know what you think about this one. So I'm in the middle of a 3-day fast. I'm about 1 day in. First day is dry, meaning that I'm not going to drink any water or eat anything. That's what the dry fast is for. And then tomorrow morning, I think halfway through, about a day and a half in, I am going to start drinking water, but not eat for until the end of the weekend. Basically, and it is a little bit tiring, honestly. But yeah, I usually fast about once a quarter. If you watch my videos from the past, I would talk about it from time to time. But you know, with the marathon training and all the exercises, I kind of put it off. And you know, this is now I'm beginning to ramp up on a new cycle, so this is probably the best time to do it and just kind of rest for the weekend. I don't know. We'll see how it goes. I'm a little tired. I don't know. Well, I mean, I guess I know why. I'm a little bit tired, but yeah, let's take a look at today's problem. Today we have 1861. Rotate the box. You're given an R by C matrix of characters, box representing a side view of a box. Okay, each cell would contain one of the following: a stone, a stationary obstacle, and an empty thing. The box is, I don't remember doing this, apparently I did though. The box is rotated 90 degrees clockwise, causing some of the stone to fall to gravity. Each stone falls, and then now you have to go. Okay. Yeah. I mean, I think we're just rotating, and then now let gravity do its thing. And there are obstacles in which it doesn't fall through, right? I mean, I think, okay, so the first thing is just that we should rotate it, which should be, you know, straightforward to do. I don't think there's anything that difficult algorithmically, so I'm not going to talk about it that much. Let me know if you have any question about it. But the idea, I think, is going to be the two pointers thing, right? Or two fingers, sorry. Which is that when you look at gravity, you go, okay, what is the next empty slot? Taking into account obstacles and stuff. And then the one go before that, or the one that's on top, will be the current thing that we're checking for to see if it falls. That'll probably, that'll keep it linear-ish, right? So that is why we want to do it that way. Otherwise, you're going to add in, like if you do like a for loop inside, then it's going to take another over or in this case, or maybe of C because you rotate it, so it's a C. But yeah, so okay. So the first thing we want to do is rotate, right? And then maybe, we have new boxes. You could, right? Let's just start with, yeah, just start. No, it doesn't matter. Well, I want to write this, but of course this is going to be wrong because now this is rotated, right? And then we just return new box after we rotate it. We didn't rotate it yet, though, obviously, because, even though I'm tired, I'm not, well, actually, I guess sometimes I am. But yeah, so rotate, we don't let it fall yet, right? So here, new box of ij, of ji is going to be equal to box of ij, maybe? No, that's not right? Because that's just a transpose. So what you want to do is, to be honest, I always forget which way it goes. It doesn't really matter as long as, you're consistent. And also the thing with this is that I find it very often it's easier to just print it out, right? So in that case, we'll just print it out and then we'll see how it goes. Yeah. Ooh. How'd I? Alright, maybe I am that tired. But yeah, so here you have this. It should give you this, which is what we expect. Of course, the first example is kind of not great, right? Because it's symmetric, so we don't know which rotate it is, so it doesn't help. So this one we want to see. Okay, so this one, for example, we have this, and then after we rotate it, it should be this. And here you can see that we rotated the wrong way, so that's fine, right? You can also rotate it 3 times, but that's fine. So we'll just rotate the other direction instead. Right, double check it real quick. And as you can see, it's just much quicker, at least for, I mean, you should double check it even if you are confident. So this just makes it a bit better if you ask me. Yeah, so this is the input. And then, ooh. This is not right still. Oh, no, this is right. We just didn't let the gravity do yet. of course, which makes sense because we haven't encoded that yet. Okay, so then now we have our box is equal to rotate box, right? Okay, so now the box is rotated, and then now we have to let gravity do its thing, right? So how do we want to do it? As we said, for each column, you could basically treat them independently. Maybe I don't even need it. I mean, okay, let's keep it. Well, no, yeah, okay. Keep it consistent in the new C. But C is different now, right? So maybe we should write R is equal to length of our box. C is equal to length of, you know, just so that we're in the new world. But okay, so then now, yeah, so then now for each thing we go down, right? So for each column we're going to consider what we want to do, and yeah, and downward is actually in this case going to be positive I, right? So that means that, okay, so we want two things, right? We want the last wall, what's it called, obstacle? Yeah, let's say last obstacle, right? Except for that last obstacle is going to be maybe even not last obstacle, just like last free space, right? And then current cell is what we're going to do, which is for current in and this is going to be 0, I guess, just because it kind of goes with what needs to be, right? And then start at 0, and keeping in mind that technically last free could be itself, right? So that would be fine, because you could say that you remove it and take it, I don't know. But yeah, so then now if our box of the current row of J, right? If this is equal to, there are only a couple of cases, let me double check. So if it is empty, then of course last free is equal to current, right? And we get to update it in the future. Else, and this is where I should actually use the, I keep on saying that I should, and then I keep forgetting. So I'm going to change it real quick, which is to use the switch statement syntax, right? I don't know if it's more performant, honestly, though. I should probably double check that. But yeah. And then we have a thing, an obstacle, or maybe just do a stone first, right? Stone first, we said last free is equal to current plus 1, right? Because, oh, actually this is kind of wrong. Because if you kind of move it up, then it doesn't make sense, right? So last free is equal to current plus 1, and yeah, I think we'll, and then else, so then the other thing is just the obstacle, right? Well, and then, oh, I confused obstacle and stone, sorry. That's why I was like, okay. So on the obstacle, you know that the last free is going to be the next one, or at least the next one, right? And then when you see a stone, then now you want to drop this to the last free, right? So then we want to say our box of current of J is equal to right, because we drop it, and then we drop it to last free. So our box last free of J is equal to the stone, and then we want to say last free is going to be equal to increment by 1, right? That will always be the case, because I think that this is the tricky part that I want to kind of, yeah, with the two fingers, is that the last free will always be 1 greater than this, because by definition, everything in between current and last free should be empty space, right? So that's the invariant. I've been talking a lot about invariants more and more, and these are the things that I think about, right? And when you try to do your proof, you're like, okay, well, in every loop, that's always going to be the case. So then now you can make different assumptions and also different things to make sure that the case is true. Anyway, and then now we have the default of, I guess, just empty. Empty, I guess we don't do anything, right? So we just continue, I think. Could be wrong here. Anyway, and that should be really it. Yeah. Let's give it a spin. Apparently we're very wrong. Did I just go the wrong way? I mean, I definitely went. Oh yeah, I did go the wrong way. Whoops. Okay, fine. Because I dropped everything towards 0 because we're going from 0 up. Yeah, so we actually went the other way. Whoops. But now it just gets a little bit trickier because now the last 3 should be r -1. This should be current -1, and this should be you know. Okay. Way easier to make mistakes. So I mean, I even said I should look out for this, and then I just forgot it. Am I confident enough? I don't know. Let's give it YOLO submit. Huh? Kind of. Even with a linear solution, you see that it took 2 seconds, which means that if you had done like another for loop, it was going to be too slow. But yeah, I mean, I think the key. I mean, there are 2 problems in this one, right? One is the rotating. I think the rotating is not that bad. There are only 2 ways you can rotate, so as long as you do it kind of reasonably okay, that should be okay, right? And then the other thing is the dropping, right? The dropping is a little bit tricky, but there are 2 key things. One is noticing that each column acts independently, so you could care about a column at a time. And then the second is the invariant, what I was saying about with the dropping, which kind of makes the code kind of pretty, if you will. But yeah, what's the complexity here, right? Well, it's going to be linear time, linear space, right? The rotate is going to be linear time, linear space. You're going to look at every cell once, and it's going to take linear spaces because that's the size of the output, right? And of course, this is also linear time, linear space. Well, I guess I did it in place here, so I guess it's not linear space. But yeah, you look at each cell at once, so that's going to be linear time. And just also to be clear, I say linear time because linear is in the size of the input, and the input is r times c. I know that sometimes people may say that this is n squared, but that's fine, even if that's the case. But it's still linear in the size of the input, because the size of the input is n squared in that case, and the size of the time complexity is n squared, which is linear in the size of the input. That's usually what people mean. I mean, just a little bit of a thing, but you can also just say it's O of R times C, then there's no confusion about what it is. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. I am really thirsty, so I am going to go back to bed and take a nap. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.